In this video, I will be using the tabular method to multiply two polynomials. We're going to be multiplying this polynomial up here by using a tabular method. The first step in the method has been done is to determine the dimension of the table. As we can see here, that this first factor has 1, 2, 3. So it has 3 terms. The second factor has 1, 2, 3 as well. So it has 3 terms. So, and then there is no missing terms. And so you see it goes from 2, the exponent goes from 2, 1, and then constant term. The same thing here, exponent goes from 2, 1, and constant term. There are no missing terms in any of the factor, either of the factors. So we are set. It's going to be a 3 by 3 table. And then so you have 3 rows and 3 columns. So there's 3 rows and 3 columns. And now the first step in this process is to place one of the factors on top of the table, and then the second factor down the right side of the table. Okay, top and right side. Then we're going to start multiplying each term by each term from each expression by each other to fill this table up. So for example, the first term, the first expression coming to the top left box in this table will be x squared times x squared. Now you have to remember from basic algebra 1 that if we are going to multiply x squared by x squared, x squared by x squared, basically you will be adding the exponents together. So we be x to the 4th. So that's why x to the 4th is going to come into this box over here. So x to the 4th. So we're going to continue the process by multiplying x squared times 3x squared. So remember, we're going to be multiplying the coefficient 3 times 1. When there's nothing right here, it means there's a 1. So 3 times 1 is 3. 3 times 1 is 3. All right. And then the x squared times x squared times x. Let's see over here, x squared times x, which is like, add the exponent together will be x cubed. So x cubed over here. So that's why the content of the next box will be 3x cubed. Cube is coming up there. And that's why we have that. Negative 5x cubed over here. Now, actually, I was filling the rows up first, so I need to start all over again. Now, we are going to go to this other box over here, the next box over here, which will be x squared times 1. X squared times 1. So that's easy, pretty easy. It's just going to be x squared up here, so it'll be x squared over here. All right. Then we're going to go to this other box, which I already did ahead of time. Not necessarily so all the time, but just to review, you would do negative 5x times x squared. Negative 5x times x squared. So 1 times negative 5 is negative 5. And then x squared times x is x cubed. That's how I got this other entry over here. Okay. Here already, and then we go to the next box. We do exactly the same thing. We're going to do the 3 times negative 5 with negative 15, and then x times x is x squared. Okay, go to the next one. We do the 1 times negative 5 is negative 5, and then this x is just by itself. Okay, x times 1 is just x. And now we go to the next one. We do this 1 that's up here, 1 times 2, and then 2x squared over here. All right. To the next one, this 3 times 2, this 3x times 2 is 6x over here. All right. To the last one, 1 times 2, which is 2 over here. All right. Now that we have gotten all the content of this table, everything is filled out. Now we are going to combine like terms. That's the next step. We're going to combine like terms. To do this using this method, we will need to look at the diagonals. We'll be looking at the diagonals across the table. So we will do each diagonal should sum. We add all the content of each diagonal, the sum. So here the first one is only one term, only one expression in that diagonal. So it's going to come out to be x to the 4th over here. That's along the diagonal is only one. So here is x to the 4th. The next one is the next diagonal is going to add. We're going to add these diagonal elements together. So we have, let's add the coefficient. So 3 plus negative 5 will be negative 2. All right. And then since we're adding like terms, this s cubed stays the same because they are like terms. So the negative 2s cubed. That's what we got coming out from this diagonal. Negative 5s cubed plus 3s cubed is negative 3s cubed. Because they are like term, we're keeping the exponent the same, negative 2s cubed. Remember, we never add the exponent whenever we're doing addition. We're keeping the exponent exactly the same. Okay, so to the next diagonal. The next diagonal, we're going to add this coefficient 2 plus negative 15 plus 1. There's a 1 there. So 2 plus negative 15 is negative 13. Negative 13 plus 1 will be negative 12. So when we add this diagonal together, it comes out to be negative 12x squared. All right. We go to the next diagonal. We're going to add the 6 and the negative 5. 6 plus negative 5 is 1. 1x. 1x is just x. So x is coming out from this diagonal. And last one, which is just this one last box over here. It's only one element, and it's just going to come out as 2 the way it is. This is your final answer. Which is just, we've added all the diagonals together, and now all we need to do is to write everything around this table. We're going to write all of this element, all of these things that we added over down here. We're going to put them together in one single piece of expression. Our final answer. This is the final answer I was talking about. So you go, all this is the product, is the result of multiplication of these two things together. We get this. So quick review. Basically, you set up the table by using the each factor, determining how many elements in each factor, how many terms in each factor. That's the dimension of your table, and then you multiply each element, and then add them all together by the diagonals, and then you have your answer. Well, that is how you use the tabular method to do multiplication of polynomials. I hope this helps. Bye.